Welcome. Here we're going to be learning how to solve exact first order differential equation. Previously we learned what a differential equation is, and we also narrowed it down to a special case exact differential equation. We said that if a differential equation is of this form, m of xy dx plus n of xy dy equals to 0, where m and n are functions, that equation is exact if and only if I differentiate m with respect to y and I differentiate n with respect to x, and the both values are equal. That's quite simple, right? Differentiate the part that have x with respect to y, differentiate the part that has y with respect to x, and you're done. Now this implies that we can find a new function, because the aim of solving differential equation is to get an answer, right? Y of x. So now we can find a new function f of xy such that if I differentiate f with respect to x, right? If I differentiate this with respect to x, we have m of xy, and this goes because it's a solution. So now the same thing, if I differentiate this equation with respect to y, this whole thing goes, and we have this just standing alone, n of xy. This simply tells us that this function is simply the derivative of f, right? So derivative of f is equal to that. So now equation 1 and 2 gives us that the derivative of f of xy is simply the sum of this with respect to the x and the sum of this with respect to the y, which is the same thing as equation 1. Now how do we solve this given equation? Because this is the equation we are given, we need to get f of xy. So the first thing, if you have an equation of this form, this is derivative, right? You need to integrate. So if I integrate that, I will have that f of xy, because the d will cancel the integral part, f of xy is equal to, now it depends on what I'm integrating with respect to. I could choose to integrate with respect to x or choose to integrate with respect to y. Now, knowing that if I integrate with respect to x, f of xy is equal to the integral of, integrating with respect to x, m of xy dx plus, we don't neglect this y part, we know that it will give us another function of y. So that's step 1. Step 2, simply differentiate. See, solving exact equation is just as simple as IDI. Integrate, differentiate, integrate. So here we are going to differentiate again. Now the reason why we are differentiating is because we need to know what g of y is, and to get this g of y, we need it to be able to equate it to something. So this gives us another df in a beautiful form, which is still equal to this df, right? Is equal to, this is a new function, because I'm integrating now, I'm differentiating now with respect to y. My aim is to find this, so I have to integrate with respect to this function, okay? So I'm now integrating with respect to y, and I have the f of xy is equal to, this is a new function, right? Let's call that function q of x. But you know I'm differentiating this function, so it becomes prime, plus, let's not forget how I got that q of x, plus g prime of y. So this should be q of xy, because m is a function of xy. So my q of xy, let me write it here, q of xy is equal to the integral of m dx, just for you to know. And then finally, remember I told you it's as simple as IDI. If I have this, I can easily equate it to this function, right? So whatever I equate to this function, since this will be a given value already, g prime is just the unknown we have, so we equate it to this, and whatever is left after cancelling out or subtracting, we have that is equal to g prime of y. So I need g prime of y to become g of y. I'm integrating g prime of y to get g of y. It's very easy. Once you start solving, you see it. So I'm going to now give you the process explicitly. Follow me as we go. Method of solving exact differential equation. Steps written out clearly. My f of xy will be equal to, I have that my f of xy is equal to integral of m of xy dx plus g of y. Now this g of y is just a function of the other variable that we are not integrating with respect to. So if I integrate this f, the df with respect to y, I'll have f of xy is equal to integral of n of x y dy plus gx. So that's the first step. So let's just call either of this to be q of x, y. Next, we need to find the unknown function g of x or g of y, respectively. Any one you are using, you don't have to use the both. That's why you said or. So anyone you are using, just use the one that is easier to integrate. Okay. So anyone you are using, you need to find the corresponding g function. So I'm going to differentiate. First, remember we said integrate, then differentiate. So I'm going to be differentiating this function, the f of x, y, with respect to the corresponding function. That's what g is a function of. So this will be q prime of x, y plus g prime of whatever function it is. And we're almost done. Next thing to do is simply integrate whatever you have here. You know, we said we are going to integrate this with the original function, right? You're going to compare this with the original function that we called 1. That's m plus n that we called 1. So finally, we integrate with respect to the variable that g is of, and we are done. So thank you. I hope you understand. Simple processes: integrate, differentiate, integrate. Thank you.
Please subscribe, like the video and hit the notification bell for more videos. Thank you.